everybody. Today is Wednesday, October 6th. Our objective today is by the end of class, I want you to be able to tell me what the Earth's outer layer is like underneath the surface of Earth. Our activity will be in plate motion, chapter 1, lesson 2. And if you were absent, you're going to look inside this folder for all the PDFs that you missed in class today. And your homework for everybody is to read and annotate the short article, The Ancient Mesosaurus. Let's go ahead and go in. Yes, let's go in. If you were absent today, you're going to see your folder. Look here if you were absent. Or if you were in class but you've lost your worksheets, you can find those worksheets in here. So the first PDF is our closure activity. It's Earth's outer layer. It's just like a really rough sketch of the continents on Earth, and I'll talk about that in a second. And then the second one is the Ancient Mesosaurus article. It's a really short article. It's just one page, just a couple paragraphs talking about the Ancient Mesosaurus. And that's your homework assignment. You're going to read and annotate that article. So if you were gone today, go ahead and pause the video, copy both of those into your plate motion folder in GoodNotes, and then go ahead and resume the video. Come on back. Okay, so this is just a review for those of you who are in class and just need a review, or if you were gone, this is just a very quick summary about what we talked about. The kids started out today with a warm-up where we just talked about fossils. What do they already know about fossils? We talked about how some people find fossils in rocks. We've got lots of fossils around Nebraska because Nebraska used to be underwater. So we've got lots of marine life fossils in Nebraska. We talked about paleontologists and how they take a look at fossils of dinosaurs in order to help them tell a story. And that's basically kind of what I was getting at, is that fossils help us tell a story about Earth's past. So we are looking at, we took a minute to watch a video. And if you were absent, you don't need to watch this video. So I'm going to skip that and go to our unit question. The unit question is, why are fossils of species that once lived together found in different locations on Earth now? And specifically, let me talk to you about this email. So Amplify created this scenario for us. We are now student geologists, and Dr. Bayard Morago is the lead curator for the Museum of West Namibia. And the subject is Mesosaurus fossils. Now, even though this is a fictitious scenario, the information, remember, that Amplify uses is actually real. So there really was a type of ancient dinosaur called Mesosaurus. And let me just read the email to you. It says, we're lucky to have a fossil specimen of Mesosaurus to display in our museum. And that's what that is, a picture of to the right there. The fossil remains of this organism were found in hard, solid rock near our museum in southwestern Africa. Fossils of Mesosaurus that originally lived at the same time and in the same place are also found thousands of kilometers away across the Atlantic Ocean on the eastern coast of South America. So this is very puzzling because this ancient animal could not swim very far. So then why are Mesosaurus fossils found in South America and Africa, continents that are now thousands of kilometers and an ocean apart? Sorry, I've got messages from people who are getting their eyebrows done. Sorry if that is coming through. Anyway, so they're trying to figure out how come they find fossils of Mesosaurus both in South America and South Africa. So that's our role in this unit. We're trying to figure out what's the explanation here. Mesosaurus couldn't swim. And so there's really no simple explanation for why we're finding these fossils in different areas of two different continents that are separated by an ocean. So let's keep going. In this unit, you'll use your understanding of geology to explain what happened to the rock that Mesosaurus fossils were found in and why the fossilized remains of these reptiles that once lived together are now found so far away from each other. So let's think like geologists and consider Dr. Moraga's question. So there's South America, there's Africa. The green space is where there is evidence of fossils. In other words, the fossils have been found in the rock in South America and in the rock in Africa. But how did that happen when they are thousands of kilometers and an ocean apart? So our chapter 1 question is, we need to kind of figure out what's the land like where Mesosaurus fossils are found. I don't really like how Amplify worded this. Really what they're asking about is the geosphere where Mesosaurus fossils are found. So if you remember, when Earth scientists think of Earth as a whole, they think of it as a system. Remember this graphic from last unit? So a system is a set of interacting parts forming a complex whole. And all the Earth system is made of parts called the spheres. And we're really going to be focusing on the geosphere, okay? So we're going to investigate this question. What is the Earth's outer layer, or the geosphere, like underneath Earth's surface? And if you remember, your objective was you're going to be able to answer this question by the end of the class today. So one way scientists learn more about Earth's outer layer is to use large drills to collect samples of the land below the surface. This is called scientific drilling. And if you take a look at that guy up on the top left, he's looking at these cylindrical samples. So what happens is, sorry, my dog. The drill goes down and collects these core samples and then brings them back up to the surface of Earth, and they're uncased and laid out, and then scientists can kind of take a look at what they are made of, like super deep. There's 3 different types of drilling. There's land drilling, there's drill ships, and they drill through the ocean and then down into the sand and down in the bottom, and then ice drilling, ice-based drilling. So a core sample is one way that scientists can learn about the interior of Earth. And from these core samples, scientists can then make special visual representation called cross sections. And hopefully you guys remember when you were doing your vocabulary yesterday that a cross section is a diagram that shows what the inside of something looks like. So if you took a picture and you sliced it in half, that's a cross section. To investigate Earth's outer layer, I had the students and their table partners read about one of 4 scientific drill sites. And I'm going to jump out of here, go into Amplify. And in activity number 3, you're going to see down below, you've got different numbers. There's 2, 3, 4, and 5. I'm going to let you guys read each one of those 2, 3, 4, and 5. Pause the video, read through that yourself, and then come on back. Okay, so we kind of talked about it in class. I'm going to summarize what we talked about, okay? So the first core sample was a cross section. Remember, cross section is where you would just take the circular core, cut it in half, and look inside of it. That's what it would look like. So this first one was taken at Colorado Plateau Coring Project. So this is in Colorado, and it's over 500 meters into the surface of the Arizona desert. Okay, it's not in Colorado. I lied. Sorry, it's in Arizona. So you would think that it is, all sandy. But if you look at the cross section, it shows from 0 meters to 17 meters that it's hard, solid rock formed during volcanic eruptions. In other words, this is lava. This is hard, solid rock that's lava. And then underneath that, from 17 meters to 500 meters is hard, solid rock formed from sediments. Cool. So when I say what is Earth's outer layer or the geosphere like at this site, we can say that it is made of hard, solid rock. Well, let's take a look at another one. So a team with the Hawaii Scientific Drilling Project drilled over 3,000 meters into the surface of the Mauna Loa volcano. And the core sample the team took revealed that underneath the surface, the volcano is made of hard solid rock that formed when lava cooled during many different volcanic eruptions. And you can see in the core sample picture on the right, see all those lines, the kind of black lines that are horizontal? That indicates a different period of volcanic eruption. So we know that there was one on top of another. But when you look at the cross section on the left, it just says from 0 meters to 3,000 meters, it's made of hard solid rock. So according to this core sample, Earth's outer layer, or the geosphere, is made of hard solid rock. Let's look at the third one. So now this is an example of ocean drilling. And so this is off the coast of Mexico. To reach the land at the bottom of the ocean, the team had to send the drill down through 3,800 meters of water. And we see that represented on the cross section from 0 meters to 3,800 meters. It's just water. But then from 3,800 meters to 4,000 meters, we see sediment such as mud and sand. Think about that. If you were able to remove all the water off the surface of the earth, what's underneath the water in the ocean? It's got to be mud, silt, and sand, right? Well, when you get below the sand, what's underneath there? From 4,000 to 4,014 meters, hard solid rock. Hard solid rock. So according to this core sample, what is Earth's outer layer or the geosphere like? It's made of hard solid rock. And if you look at the fourth one, I'll bet you can guess it, but this is kind of cool. So there's a real project called Andrill. It's real. I have actually had a science professor of mine, my geology professor at the University of Nebraska in Lincoln was a scientist here on Andrill. It's a bunch of scientists from around the world who go to Antarctica and they drill through an ice shelf in order to reach the land at the bottom of the ocean. And so this is directly from that team. And you can see from 0 meters to 85 meters, they had to drill through ice. And so you just see that ice. And then from 85 meters to 935 meters, it's blue. That's the ocean water. But then you get down to the hard solid rock formed from sediment. That's from 935 meters to 1435 meters. And then underneath that, what do you get? Hard solid rock formed during volcanic eruptions. So, for the fourth time, according to this core sample, what is Earth's outer layer, or the geosphere, like at this site? And of course, it's made of hard, solid rock. So when we come back to our ideas about the investigation question, what is the Earth's outer layer, or geosphere, like underneath Earth's surface? And it is, everybody say it loud, say it proud, hard, solid rock. Okay, so the outer layer, vocabulary. Your outer layer is Earth's outermost layer of hard, solid rock that's underneath the soil, vegetation, and water. If you could somehow take all the vegetation, all the soil, and all the water off of Earth's surface, you would reach the outer layer. Another name for the outer layer is the mantle. And so Earth's outer layer, or Earth's mantle, is made of hard, solid rock. That's your first key concept. So if you didn't write it down before, I want you to pause the video and write down key concept number 1. Earth's outer layer is made of hard, solid rock. Lastly, you've got a closure activity. If you were gone, this is in your folder. I want you to show what you've learned by using a pencil or a highlighter to shade the regions where Earth's outer layer is made of hard, solid rock. Okay, where is Earth's outer layer made of hard, solid rock? Go ahead and do that and show that to me when you come back to class, okay? Your homework assignment is to read and annotate this very short article about Mesosaurus. It just gives you some good background information that I want you guys to consider so that we can bring it up in our class discussion tomorrow. All right? Cool. I'll talk to you guys later.